Well, good afternoon, everyone. Thank you for joining today's webinar on data centers' impacts on energy, water, and air systems. My name is Christopher Jordan. I'm a senior specialist for innovation at the National League of Cities. We're very pleased to host this discussion today in partnership with the American Association for the Advancement of Science. Before we dive into today's presentation and discussion, I'd like to provide a quick background on who we are at the National League of Cities and why we're taking an interest in data centers. Next slide, please. The National League of Cities, or NLC, we are the leading voice for cities, towns, and villages across the U.S. Our mission is to strengthen local leadership and advocate for the interests of local governments on the national stage. As an association, our membership includes 2,700 local governments who altogether represent 200 million residents in the U.S. We work across all areas that municipalities have to consider, and we do that by providing no-cost technical assistance, peer-to-peer learning opportunities, and federal advocacy. And NLC has been around for a while doing this. We actually celebrated our 100th year as an organization last year. Next slide, please. So our sustainability and innovation team supports cities through a variety of programs. We take an all-of-government approach to addressing climate and the environment, and we emphasize the value of sustainability and a healthy environment beyond a crisis mindset. Our work asks how these elements can make our everyday lives better and help future generations thrive. We provide specific TA opportunities, tools, and guidance, but we're also here to support municipal governments as they navigate a number of challenges by connecting leaders to the right people and expertise. Next slide, please. On the topics of data and emerging tech, we're helping local leaders understand the opportunities and risks associated with AI-powered tools. We published a report and toolkit last year to help demystify generative and predictive AI in the public sector context. And we're helping local leaders engage their staff and communities as they deploy new solutions. We also developed an AI governance dashboard to help cities learn from other city AI policies so that they can create responsible guidelines that work for them in their city. We're also working on a series of fact sheets and webinars, including this one, that focus on the growth and impact of data centers. So why talk about data centers with respect to local governments? Next slide, please. So as AI is expanding, the National League of Cities has heard many concerns from local leaders as to what the effects of AI and data centers are on sustainability. And this issue is, of course, being more widely discussed. We've heard questions from local leaders asking how data center development and operation align with city climate goals. We're also hearing about questions on local return on investment related to jobs, tax revenue, and infrastructure strain. And we're hearing questions on what authority local governments have to shape responsible development. So throughout our conversations with local leaders, we've heard three main themes that we are aiming to address through this webinar series and a series of fact sheets. The first theme is that while data centers can bring economic benefits, they often place significant strain on local resources, as we will touch on today. Another theme we've heard is that these facilities don't always fit cleanly into traditional land use codes, which can create uncertainty for local officials and planners. And we've heard a need from local leaders for clearer data and tools to evaluate the long-term trade-offs and determine appropriate local responses, policies, and ordinances. Next slide, please. So, as I mentioned, we have some work planned on the horizon to address these questions. We're gathering ordinances and policies around the country of cities and local governments that have considered the impacts of data center development in their localities. We're also holding educational opportunities to hear from communities and engage with them and discuss with them about data centers and AI use and local impact. So in addition to this webinar today, we will host future conversations that will focus more on grid impacts as well as community impact and local policy responses. And lastly, we do want to hear from you. Next slide, please. So we would love to hear from you all, whether you're a city leader or an expert or someone within industry attending, about what challenges is your community facing and the information and resources that would help support local decision making on these topics, and of course how the National League of Cities might be helpful. I'd like to thank you all again for being here and to our speakers. And now I'd like to hand it over to Kate Stoll from AAAS.
Thanks, Chris. Appreciate it. I'm Kate Stoll, Project Director for the Center for Scientific Evidence and Public Issues, or EPI Center for short. Our mission is to bring trusted relationships between scientific experts and decision makers at all levels of government to make it easier for policymakers to access and incorporate scientific evidence into their decision-making processes. We're a part of the American Association for the Advancement of Science, which is the world's largest multidisciplinary scientific society. And we're so thrilled to continue our collaboration with the National League of Cities to co-host this webinar. So before I introduce our moderator, I want to take a quick poll of the audience. So if you wouldn't mind pulling that up, Joanna. What are you most interested in learning regarding the increase in data centers around the country? I'll give just 15, 30 seconds to reply. Thank you for everyone's quick responses. We'll show you the results in just a few seconds. All right, so I'm going to end the poll, share the results. We're seeing across the map, but certainly a lot of energy and water questions and interests, which is perfect because we have two folks today who know a lot about these. Thanks for responding to the poll. Appreciate it. So now I'd like to introduce our moderator, Arthi Garg, who's Chief Technologist at Aviva and Chair of the IEEE Environmental Impacts of AI Working Group. You can read about her extensive experience in both government and the technology industry in her bio, and I'll put a link to her bio in the chat. I'm also adding 2 links to work by Arthi and her colleagues on the energy and water footprint of AI, so I encourage you to check those out. So with that, I will hand it over to you, Arthi. Thanks.
Thanks so much, Kate. Thanks everyone, first of all, for your interest in this topic. I think it's a really important topic, and particularly the framing around, how do you think about data center growth through the lens of decisions that local governments are having to make right now. I'm not going to spend too much time here because I really want to turn it over to Chalet, our expert, to talk about some of the resource impacts associated with data centers. But I wanted to just kind of set the stage a little bit because, first it can be useful, and I think Epicenter, Kate probably is going to share the link in the chat, but the Epicenter and NLC have put together a nice kind of fact sheet around this, but just so that we kind of are all using the same language, what is a data center? We're talking about how they're going to impact water and electricity, but just make sure we're all talking about the same thing. So in sort of very basic term, a data center is a facility that houses large amounts of compute. Historically, maybe they've been used for things like your email servers or e-commerce sites. Sometimes you'll have an e-commerce site might actually deploy its software in a number of places so that especially the images that are used can get to end users more quickly. We've been seeing, though, in the last few years, particularly with the advent of these very, very large AI models, that there's been a significant growth in data center demand, and then that leads to a significant growth in the resources that are used by data centers. What does a data center typically consist of? So it's the building itself, and then that has sort of attendant systems associated with it, like building security. Then you can kind of think about a data center having 2 kind of sides to it. So we talk about the white side of a data center, and that's usually the computing itself. So it's the servers, the networking, the racks that house the computing servers. And then we talk about the gray side, which is the sort of more facilities infrastructure. So that can be the heating and cooling systems, the power systems, any of the kind of plumbing that you might think about. And we're really, when we talk about really understanding the resource implications of data centers, it's the gray side that we're talking about of the data center. From the perspective of local governments, local decision making, why does this matter so much, though? It might seem like this is sort of a technical thing. Well, it matters because of what I mentioned around AI and the growth of demand around the need for computing, which leads to growth and demand for data centers. Some of the statistics I have as of today, there's more than 5,000 data centers in the US. That was a couple months ago. It could be 6,000 by now. These are resources that are coming online very, very quickly. It can be difficult to get exact estimates, but these data centers consume something between 4 to 5% of the electricity that's generated in the US. And there's a lot of projections on how fast the demand of these data centers are going to grow. And I actually hesitate to quote these numbers because they vary so widely. But let's say it's not totally unlikely that data centers could potentially consume up to double-digit percentages of electricity generation in the US by 2030. So that's 5 years from now. And one of the things that, one of the challenges around actually making an accurate prediction around that is that there's a lot of lack of transparency around what the environmental impacts of data centers are today, what their actual water usage is, what their actual electricity consumption is today. I won't go into them, but there are stories of data centers where people had to use FOIA to get information around what the data center builders were even estimating would be the water usage associated with their data centers. So there's a huge amount of lack of transparency, and we'll use that as a way of putting in a plug for joining the working group around environmental impacts of AI standards working group that I chair, because we really need as many people as possible sort of thinking through how we measure these impacts and surface them in a way that is consistent across providers. So, and the other reason that I think a lot of local governments are asking questions about siting data centers is that data centers, for very practical reasons, are often located close to population centers that can reduce networking latency and costs associated with transferring data. And so that's one of the reasons that you'll see, and then there's also just questions of where is their land in order to site a data center. But some of this then translates into questions around economic impact. And one of the challenges associated with data centers is that once they've been built, there are often very few jobs that are ongoing associated with them. So data centers can operate on very, very thin staffs. I've been to very large hyperscaler sites where they maybe have 5 or 6 large buildings housing compute, and the total staff on site is maybe less than 10 total, and at night maybe even just 1 or 2. But in addition to that, there are some real impacts that data centers can have on local utilities that includes electricity demand, electricity quality, and water usage, as well as land use. And so that today is really kind of the focus of our discussion. So I'm going to turn it over now to Xiaolei Ren, who is an associate professor of electrical and computer engineering at the University of California, Riverside. Kate will drop in a lot more information about his extensive bio working and background working in these areas, but I don't want to take any more time away from you, Xiaolei, so I'm going to turn it over to you.
Thank you. Thank you so much for the introduction. And for laying the background on what is a data center. So I don't have to go through the explanation of what is a data center. So yeah, as we said, data center just is a, you can imagine data center as a 5-star hotel, but not for people, but just for servers. And and what makes an AI data center so different from traditional data center is the power density. So if you have a, let's say, a warehouse scale data center for the old generation web services, the power demand is probably around 20 megawatts to 50 megawatts. That's already pretty large. But nowadays, the same size of data center can go up to 200 or even 500 megawatts. So the power density that creates that high power density creates a lot of the heating problem and the grid capacity problem. So yeah, I'm gonna share some of my recent research on estimating and addressing the hidden environmental and public health impacts of AI. So let me start. Yeah. So before talking about my own work, I'm gonna share. I'm gonna be sharing some of the critique on the research of AI water. For example, the CEO of a leading AI company said, you know, the study on AI water just something made up by those anti-AI crowd. Well, I checked my publication list, which has about, you know, more than 100 papers, but just a couple of them are about measuring and understanding the environmental impacts. All the other papers are about optimizing the system, how we can make the system more efficient, more sustainable, and how we can better design the network architectures. So I don't really think I'm a anti-AI person, so I don't really know whom they were referring to when they use the term. So anyway, so this is the formal disclaimer. And this talk is not really about stopping the AI development. Instead, we try to provide some quantitative assessment of the environmental and public health impact to support informed decision making. So as RTA has already said, and we already know that this AI demand is increasing dramatically. It's expected to continue the growth. So it comes with the huge energy demand. And of course, there are many different versions of the estimate and predictions, and it's hard to come up with some so-called accurate estimate. So here I'm showing you one of the estimates provided by the Lawrence Berkeley National Lab. So this estimate was published last year in December. So it shows that in 2028, the US data center energy demand could be consuming up to 6 to 12% of the national electricity demand. And this is at the national level. If you look at certain states, let's say Virginia, the percentage is even up to 50%. So just imagine half of the state's energy is going into electricity is going into data centers. So this huge energy demand, I mean, if you just use energy, actually, I think it's pretty good because that means you can serve more users. But unfortunately, there's a cost associated with using energy. The first thing is we have to build more infrastructures and more transmission lines, more generators need to come up online. And this infrastructure costs many billions of dollars. And sometimes the cost is shared by residents, by local communities that where the data centers are getting built. And in addition to the cost, there's also some hidden costs like the carbon emission. And just give you some quick background on the carbon emission. Typically, we classify the carbon footprint into 3 different scopes: Scope 1, Scope 2, and Scope 3. Scope 1 is the direct carbon emission, and that's for data center context, that just means it's primarily coming from the backup generators. When we operate and test backup generators, there will be they often use diesel fuels, and this burning this diesel will produce some carbon. But this carbon emission is is almost zero for data center because we don't really turn on backup generators very often. And for Scope 2 and Scope 3, these are the indirect carbon emissions. And Scope 2 is specifically for the carbon emission from the power grid. So when you use energy, there's even in the US, most of the energy is coming from fossil fuels, and that has a carbon footprint. And Scope 3 is everything else, like the supply chain, mining the rare earth and making the AI servers and chips, and recycling server and transportation. So this depending on the company's scope 2 and scope 3 carbon emission are nearly 100% of their overall carbon footprint. And sometimes scope 3 is more dominant, and sometimes scope 2 is more dominant, depending on how they calculate this scope 2 and whether they are applying carbon credit or not. So, but in general, scope 2 and scope 3 are both quite substantial. So besides the carbon, there's also a water consumption problem. The reason is the data center, data center running AI will be producing a lot of heat, and the heat, doesn't get along well with the servers. We have to get rid of the heat, and water evaporation is a very common and efficient way to cool down the servers. So let me go through some of the details. And there are many different type of cooling system. One of them, and is commonly used by some of the tech companies, and that is cooling towers. And you can see in this picture, at the right-hand side, there's a server, and it's a server room, and which contains just 2 illustrative server racks. And the server racks will be releasing heat because they are burning energy. And this heat will be circulated through a closed loop to a heat exchanger. And this closed loop circulation can be either using air, or sometimes for AI server, especially for training, they will be using direct to chip cooling. Basically, they are using some closed loop to transfer some liquid to the servers inside and then move the heat to the heat exchanger. Or sometimes they put the entire server into some liquid, special non-conductive liquid. So that's called immersion cooling. But in any case, there shouldn't be any water loss or water consumption between the servers and heat exchanger, unless there's a leak, but that's an abnormal scenario. And between the because once we transfer the heat from the servers to the heat exchanger, we cannot accumulate the heat at the heat exchanger forever. We have to further move the heat to the outside. And this is where the water consumption comes in. So let's say we're using a cooling tower, and this cooling tower, you can see at the top, there is just constantly evaporating water. And the remaining water, due to the natural evaporation process, the remaining water will get cooler, and then the remaining water will be moved to the heat exchanger and further take away the heat. And this process will be cycling several times before the water gets too much minerals and salt, and then for the remaining water, we'll just discharge it to the wastewater processing plant, and that's considered as a water discharge. So when I say water consumption, it's actually a technical term. It's defined as the difference between water withdrawal and water discharge. In the data center context, that just means the evaporated portion of water. And for the residential settings, we typically don't actually consume much of the water, although we are withdrawing a lot of water. For example, when we take a shower, we're using a lot of water, but that water is water withdrawal. And on average, for a urban residential setting, only 5 to 15% of the water that we withdraw will be considered water consumption. But in contrast, data centers, typically they will be evaporating 50 to 80% of the water they withdraw. So in some sense, they are consuming more water even though they might be withdrawing the same amount of water as a residential customers. So both water withdrawal and water consumption are important, and in many cases, they're both reported in those sustainability reports. And if you look at one of the tech companies' report, that company was consuming about 24 billion liters of water in a year. And this amount of water was roughly the same as the annual direct water consumption of a major beverage company. For beverage company, the water you put into the products, into the bottles, those are water consumption. And the same report published by the Berkeley lab also estimates the water consumption by US data centers. And they show that in 2028, the water consumption could be roughly 2 to 4 times the 2023 level due to the growing demand by AI. And actually the growth part is almost entirely driven by AI. So the water cooling tower is not the only type of cooling system. We also have natural air with water evaporation systems. Those type of cooling systems don't consume water 24/7, but when they use water during the hot summer days, they're going to be using a lot of water. So it has a high peak but low average, which is which could be putting more pressure on the water infrastructure capacity. Another type of cooling system is dry cooler, which consume very little water or almost zero water on site, but they will be using a lot more energy. So and a recent study from Bloomberg shows that the many of the AI data centers are just being built in areas with water stress, with high or medium water stress, and that's the place where water is needed most. And besides the scope 1 water consumption, if we follow the carbon emission scoping definition, there's also scope 2 water consumption. And scope 2 is from the electricity generation process. And in the US, many of the electricity, a lot, I think about half of the electricity is coming from thermoelectric. So including nuclear, coal, and natural gas power plants. And this picture shows an example of a nuclear power plant, which is using two cooling towers to dissipate the heat. And you can see the water vapor just coming out of the cooling towers. And at the bottom, there's a data center. Well, I think it's about 1 mile away from the power plant. And this data center is taking about 1/3 of the power capacity from the nuclear plant. So in some sense, this data center is also consuming water remotely. But not many companies are reporting their scope 2 water consumption. And Meta is one of the exceptions. Meta started to report the scope 2 water along with their scope 1 water consumption in their sustainability reports back in 2021. And also, if you look at the Berkeley Lab report, they specifically mentioned that if you consider both scope 1, scope 2, the total summation can reflect the true water cost of data centers. In terms of the water stress levels within the regional water resources. So we've seen a lot of a lot of comparisons of between AI data center water consumption and the some other sectors water usage, especially for the agriculture, like the hamburgers or the food industry. So they say, okay, if you eat a hamburger, they're going to be consuming hundreds of even thousands of liters of water. But that water number is life cycle, and it includes most of the number is coming from green water. Green water is a technical term, means the rainwater in the soil, and that water is to grow the grasses, to feed the cattle, to make the patties, to produce the burgers. And that's it's an entire life cycle chain, life chain. But in our calculation, we typically only consider scope 1, scope 2. This is the operational stage. We're not talking about the water to mine the rare earth or to make the AI chips. And importantly, the water for data center is blue water. It's the water in the surface rivers, in the lakes, and that can be directly accessible for human being. So essentially, we're talking about different type of water, different scope of water. Also, if you put these numbers together, it's just comparing apples with oranges. And finally, for scope 3 water, that's for making the AI chips and mining the rare earth and recycling. But there's not much information available to quantify the scope 3 water. But the only information that we have is that it's a lot. It's a huge number, but we just don't know how much it is exactly. So but these tech companies have realized the problem of their water footprint, and some of them have started to pledge water positive by replenishing more water than they actually consume. So this is sort of a offsetting method. They're trying to give the water back, in some sense, give the water back to the communities where they operated their data centers, although they are still evaporating water to the atmosphere. So additionally, Apple released a more comprehensive corporate water footprint strategy back in March this year. So they look at the supply chain, they look at the materials, and they show that about 99% of their overall water footprint is coming from the supply chain. So this really underscores the importance of looking at the life cycle water footprint of this computing industry. So finally, there's also some hidden impact related to human health. This is not being discussed a lot, but we've done some interesting research in this space. So if you look at the executive order signed earlier this year by the previous administration, and this executive order is still alive. It's one of the few that still remain alive at this point. So it's about advancing the U.S. leadership in AI infrastructure. And it's a very long executive order. But along these many paragraphs, it mentions this cancer risk. So they want to prioritize data centers in locations where the cancer risk is not higher than the national average. So this seems to be an acknowledgement of the connection between AI data centers and air pollution and the cancer risk. So why is that? Well, it's because data centers really contribute to a lot of this air pollutant. For example, for scope 1, even though we don't turn on backup generators very often, this backup generator has a really high emission rate of nitrogen oxides compared to a natural power plant. Typically it's about 200 to 600 times as much as a typical natural power plant in terms of the nitrogen oxides emission rate. So this means even though you turn on backup generator for a few hours for testing or the actual outage, or even for demand response, this could release a huge amount of nitrogen oxides that can form PM 2.5 and harm local people's health situation. And scope 2 is for generating electricity. And again, a lot of the electricity is coming from coal, natural gas, and they have this PM 2.5 and nitrogen dioxide as well. So the EPA says in the U.S. the power industry is the largest is the largest stationary source category of nitrogen dioxide, and also is a leading source of air pollutant. And scope 3 is a supply chain, so we don't have a lot of information available for scope 3. So we'll be excluding scope 3 from our calculation in the slides. So just give you some quick background on the impact of PM 2.5. So PM 2.5 stands for particulate matter 2.5. Those are the fine particles with a diameter of 2.5 micrometers or even less. So it's along with the high blood pressure, smoking, and high blood sugar. Ambient PM 2.5 is a leading risk factor for all social demographic indexes. So it can create lung cancer, asthma, heart attack, cognitive decline, and even premature death. So, and importantly, these air pollutants are cross-state. They are not limited by the state lines or county lines. They can travel hundreds of miles. In some sense, the air pollutants that we breathe in a place could be coming from many hundreds of miles away. So, but if you look at the sustainability reports published by those tech companies, they are focusing on carbon. They also report some information about water, although not as comprehensive as carbon. But they're not mentioning PM 2.5 or those criteria air pollutants at all. And it doesn't mean that, I mean, of course, they have that information. They need to report that information to the local environmental authorities, but it's just not in the public domain that people can easily access. So without this sort of transparency, I think many people would tend to assume for the worst case. For example, in Memphis, there tech companies AI data center raises a lot of concern with the health among the public. So people say, we can breathe because these data centers is burning a gas to run some gas turbines. And this is not even running diesel, and it's just they're using gas turbine to power the data center constantly due to the lack of grid capacity. But the good news is that the data center will be getting power from the electricity grid very soon. So they will be stopping using the gas turbines. And other states like Virginia and Washington have published the air quality permits for data centers. And this essentially shows what is the maximum allowed amount of air pollutants by these data center backup generators. And the Washington state even conducted a detailed health risk assessment for data centers in the Quincy area. So that I think this type of reports and assessment can really help reduce the fear, not exacerbate the situation. So using, we also did some quantification study. We used the US EPA's modeling tool called Cobra, and so it's a very easy to use tool that can help locals and state policymakers to analyze the environmental impacts and public health risk. So they will be able to tell you what is the health outcome in terms of asthma, hospitalization, heart attack, and lung cancer, and things like that. And they also convert each of the health outcome into a dollar cost and give you a total dollar cost as well as a single scalar to indicate the health risk. So this picture shows the health burden of data center backup generators in Virginia. And the first figure on the left shows the locations of the backup generators in different counties. And the biggest yellow dot is the Loudoun County. That's sometimes called data center alley or data center capital. So it has the largest concentration of data centers in the world. And the color map represents the distribution of the health risk. So the darker, the more health risk. And it turns out that the most affected county is not Loudoun, it's actually Montgomery in Maryland. The reason is Maryland has Montgomery County has more populations than Loudoun, and also it's close to Loudoun. And this somehow this wind is just taking the air pollution from Loudoun to Montgomery. And also we look at the scope 1, scope 2 together, and we look at the whole country based on the Lawrence Berkeley National Lab report about the US data center energy consumption. And again, we use the EPA tool to model the health risk. And you can see in the last few years from 2019 to 2023, each year the health risk is just about 4 to 6 billion US dollars. But in 2028, due to the high demand from AI, this total public health risk could be reaching 10 to 20 billion US dollars. And to put this number into some context, we also show the health risk of on-road emissions in 3 largest states, California, Florida, and Texas. So these on-road emissions basically are the emissions coming from vehicles and cars, SUVs, trucks, and all those vehicles on the road. And you can see in the last few years, from 2019 to 2023, the data center industry as a whole has a lower health risk than the on-road emissions in those states. But in 2028, the data center will be rivaling or even exceeding the health risk of those states. The reason is we have tightening rules, and more regulations are coming into effect for these on-road emissions. But for data center and power industry, there's a less requirement, less regulation. So in some sense, I think we need to turn our attention from these on-road emissions to the data center industry to better understand their health risk. With that, I'm just concluding my talk. Hopefully we can look at this health risk when we think about the AI data center project, and of course, we can utilize AI to improve the public health. But at the same time, it's also important to understand and mitigate the immediate health impact of AI to support cleaner air and healthier communities.
Thank you so much, Chalet. I think this was a really informative presentation, and probably the number of questions in the Q&A that I'm seeing pop up and the number of applause that you're getting in reaction is an indication that our attendees thought so as well. I think we have some time to answer some of these questions, but I'm going to start with one. There are a lot of questions in here. I've been looking at them. I know Kate and Chris have been as well. But I'm going to start with one that's maybe a little bit more, based on events that happened this week. Yesterday, Sam Altman published a blog post, which he often does, about his thoughts around data centers and the associated resource consumption with them. And he mentions in his blog post that a typical ChatGPT query uses about 0.34 watt hours of electricity, about what an oven would use in a little over 1 second. It also uses about 0.000085 gallons of water, or roughly 1/15 of a teaspoon. And, this is interesting because one of the challenges around understanding environmental impacts of computing in general and AI specifically is sort of the lack of transparency of really understanding what the consumption is associated with a specific model or a specific application. I'm curious what what you think about that and whether even these numbers track with what you would expect.
First, I think it's interesting to see that Sam Altman is using a new metric, teaspoon, instead of using hamburgers. Okay, so let's assume what they said is correct. Let's take the face value they are providing us with. So first, I think it's not really surprising that this number is getting lower than previously thought, because if they want to scale out or scale up the AI services to more people, they have to reduce the cost. And otherwise, we just don't have that resources available. Now let's come to whether the data they provided was valid or was true or not. So I think it's if you look at the energy number, that's roughly 1/10 of what many other people believe. And also, if you compare the water and number and the energy number, the water efficiency that we are obtaining from their numbers is not really consistent with what Microsoft is reporting. So this sort of inconsistency bring us up the valid is the number really the true value? And also, what does average mean? Is what model are they talking about? Because ChatGPT has many different versions of model. They have more powerful GPT-4, and they also have a lighter version. They also have reasoning mode. So it's without these details, it's hard to assess what they said is true or not. I hope it is true, because that means they're paying more attention and trying to improve the efficiency, and we can benefit the society more. But without the technical details, it's really hard to understand and just and verify their numbers.
Thanks so much, Shelley. I think, yeah, that this is one of the big challenges. And, I mean, I think you bring up an important point around the model, because, again, there's not a ton of work on this, but some of the work, some work that was actually published about a year and a half ago by some researchers from CMU, and Sasha Lucioni, who's the climate head at Hugging Face, showed quite definitively that the mode, so if you're doing image generation versus text generation, has a significant impact on the electricity usage associated with running a single inference. So
Yeah.
I think that's a really important point.
Yeah.
One
Oh,
question.
I
ahead.
also wanted to quickly add that, I mean, looking at the individual model is probably not the best way to look at the problem. I mean, we need to, look at the entire industry as a whole, not just trying to single out one particular model, right? So that's
Yeah. I think that's an important point. I'm going to ask one question that was very popular in some of the questions people sent in when they registered for the webinar. There was questions around how much work has been done to kind of understand cooling approaches that use less water, or even no water at all.
Sure. So I think this is an active research area. We've seen different test beds, different approaches. For example, immersion cooling, direct-to-chip cooling, and purely closed-loop dry coolers. And this, but in general, according to one tech company, they say that water-based cooling system can actually save energy and carbon by about 10% compared to non-water-based cooling system. And so I think if you use water wisely, it's not necessarily a bad thing. You can actually reduce your energy consumption. And also some study from Microsoft, published in Nature earlier this year, they try to quantify the life cycle environmental impacts of different cooling systems. And I think this is still an active research area. And I definitely believe that in the next few years, we're going to be able to improve both energy, carbon, and also water efficiency.
Thanks so much. So it looks like there's a question that has a lot of upvotes, and might even ask some of our friends from NLC to jump in here. But there's a question around when data centers are being sited, what are
Hmm.
the requirements around having discussions with local utilities with respect to where the siting occurs and whether there are enough resources? So I can certainly speak to any load that goes on the electric grid requires it requires an interconnection permit, and utilities take into account what the grid impact of that load would be. Shelley, I don't
Hmm.
know if you have some additional insight into that, particularly with respect to water. I'm less familiar with water siting rules, and then if anyone else from NLC wants to jump in as well.
Well, I think in terms of water, they typically they get a permit, so they will, if the water infrastructure capacity is enough to support the load, support the demand, then they will likely get a green light. Otherwise, they have to think about different cooling system, or maybe they have to build a new infrastructure to support their demand. That's something those tech companies have done in the past. But in some cases, it's quite interesting to see that they often, because water is relatively cheaper, much cheaper compared to energy costs. So it doesn't come at the top of their financial considerations. So they try to use the most economic way to cool down their systems, and that can bring up the water consumption problems in certain places. And if they're in one example in Uruguay, not in the US, those local people were not happy with the huge amount of water consumption, so they pushed back, and then the company changed their cooling system designs to a more efficient one, but that cost them more because of it consume more energy.
I would say I would add from the NLC perspective that this is exactly the issue that we would love to have more information on, that we're compiling resources, in addition to the ordinances and the policies that we're tracking, is trying to do a little process tracing on how those came into effect and if they're successful in negotiating in the development of the data center, let alone, influencing how that data center operates. So we've heard from some local leaders interest in working more closely with the public utility commissions and also other localities in the region, especially insofar as a data center in X city or county might affect ratepayers elsewhere in that region. I know we heard from some local officials in Texas about that and some regional collaboration that they're engaging with, but it's a great question.
Thanks, Chris. And it sounds like we can look for more from NLC and Epicenter around that. So maybe the next most popular upvoted question in the Q&A is one, Chalet, I actually wonder about as well.
Mhm.
And so hopefully you've got some answers to it. I think this came up with a panel we had back in February in Paris as well. But the question is, what studies exist, if any, that look at water impacts from more of a systems approach? So, not just how much water does a data center consume, and you've already talked about that's usually drinking quality water. But in addition to that, what does that mean then for water quality? Maybe because usage is being displaced, maybe there's something else that it's impacting the water system around. So, how much information is there around this topic of the impact to overall water system and water quality?
I would say for data center context, there's very little study at this point. But we definitely know that the water discharged by data centers is typically containing more minerals, more salt than regular residential water discharge. Even though you discharge water from a toilet, it's actually from the wastewater processing plant perspective, it's better than the water discharged by data centers, because the data center the water discharge has more chemicals and more minerals that's harder to process than water from the discharge water from the toilet. So but I think at this point it's the for, there's not much literature available as far as I know.
Thank you. Thanks, and that's a great question. I think an open area of study ongoing. So I'm going to paraphrase There's a number of different questions here about sort of the, I would take it as kind of the deployability of the load that a data center has. And so can it be used for demand response? What are some of the other impacts, I think, from a virtual power plant or grid services perspective that data centers can have? And so do you have any thoughts on that?
Yeah. So ideally, we want the data center to be highly flexible. That has been researched by a lot of people in the academic communities. I think back in 2010 or even earlier. So, but in reality, the flexibility that we're seeing from data centers is very limited. And there was some industry consortium established by EPI, I think last year, for pushing and maximizing the data center flexibility, but it still needs more time. And so if you look at those tech companies, they can do the demand response, and they have done a few times for using their load shifting to participate in the demand response program to save the grid from an outage. And that is a great example. But unfortunately, in reality, many other data centers, and actually most of the data centers are not those tech companies. Most data centers are third-party co-location data centers. The data center operator don't actually even have control over the servers. So they cannot apply this load shifting or the other technique. So what they do is using backup generators for demand response. If you say this is type of tech flexibility, yeah, they do. They have this flexibility, but it's not the traditional sense of a load flexibility that we're talking about. And this, if you use the backup generators for demand response, the problem is the release of nitrogen oxide during the operation, and that can be really concerning for public health. And the EPA issued a clarification in May this year that allowed data center to use backup generators for demand response for up to 50 hours a year. And well, I think if from the grid resilience perspective, this is great because you have flexibility from at least from the diesel backup generators. But from the public health perspective, this is a not so good. And yeah, I think we need more flexibility from the load, like those tech companies are doing. But this is more challenging and we'll be needing more time.
Yeah, no, I think it's, I think there were some questions in there also about people put in about cryptocurrencies. And I think with respect to cryptocurrencies versus AI training in particular, crypto mining is much more flexible of a load. And so you'll see companies that were building data centers do crypto mining thinking that they could move to hosting AI training clouds, found that because they had a lot of GPUs, found that they suffered a little bit because their cost was optimized around taking up excess wind that
Yeah.
would have otherwise been curtailed.
Yeah.
But I think, kind of continuing to draw on that thread about backup generation on-prem, there's a question in the Q&A around the usage of batteries. So, that could be one way to provide backup generation. And then also, I mean, this other trend of could you actually build a whole power plant behind the meter co-located with the data center, and then maybe that power plant, particularly if it was renewable, feed back into the grid, and some of these other ways of mitigating some of the electricity generation impact, both from a just sheer amount of electrons used, and also the sort of scope 2, 3 impacts as well.
Yeah, so building battery for, especially using battery for demand response, the problem is battery is very limited in capacity. We typically the batteries is sized for operating the data center for a few minutes, because that's only to provide the bridge between the outage and the backup generator online. Short period of time. So if you're using a battery for massive demand response, that's there will be a cost issue. So co-locating data centers with the grid, that's an idea I think a lot of companies are trying to explore. For example, some data centers are co-located with the nuclear power plants, and some of them are even trying to build small modular reactors, or they are they could be paired with some solar farm if that's possible. But although it has its own challenges, because since the place where we build the data centers are typically not a place that is suitable for building massive utility scale solar farms. So I think, yeah, if you have this behind the meter generators in a clean manner, that could help a lot to release the pressure on the grid and also to get the data center online. Because currently, if you try to get connected to the grid in Virginia, say, you have to wait for several years.
Yeah, I think that's a whole separate question, right? About modernizing our grids as well, both to deal with the kind of new types of loads and just how quickly they're coming online. I think we might have time for one or two more questions, but one that's got quite a number of upvotes is, especially you mentioned the data center in Uruguay and how kind of community members got involved, and that led to a change in the type of cooling center that was cooling equipment that was used. If you are a member of a community and your local government is having a discussion around siting a data center, what are your thoughts on the types of things local community members should be looking into, with the types of questions they should be asking or encouraging their government officials to ask?
So, okay, there are of course many aspects that we can ask for, but I will comment on two things. One is water, the other one is pollution. So for the water, I think we need to understand what is the total amount of water and what is the daily peak water usage for the data centers. And that if the infrastructure is enough to support this load, and then we, I think it's maybe the way to think about the problem is if we don't build a data center, what are we going to be doing with the water capacity that we have? So if you have the enough resources, probably using, as I said, using water is not necessarily a bad thing, because you can, reduce the energy, reduce the carbon, reduce the power demand. So yeah, I think if you have the local communities have the resource available, then just try to, if there's no other impact, I think it's fine to build data center, at least from the water perspective. And then the air pollution. So we need to understand what is the risk associated with the operation of the backup generator, so and noise pollution. So yeah, I think let's just have a open dialogue and a comprehensive assessment of the impact. If it's if it's not, it's tolerable, I think it's part of the cost that we have to take when we build a new project, whether it's data center or something else.
Thanks. So I'm trying to look at, there's a lot of different questions about permitting, which I think maybe there might be some future discussions around as well. And so I don't want to kind of steal the thunder of the future discussions, but I think we talked a little bit about kind of more water efficient data center design. Let's talk about the other utility in the room, that the more electricity efficient data center design, if there is such a thing. And you talked a little bit about power density, which might be a new term for some of the audience members. So it might be helpful for you to kind of provide a refresher around that first, as a way to kind of set the stage. And then if you have any thoughts around energy efficiency with respect to data centers.
So the power density is basically how much power we're consuming for each unit of area. Let's say one server rack, let's say 1 square feet. How much power you're using? Traditionally, probably in the 1 kilowatt or a few kilowatt, but now we're seeing multiplied by 10. So more than 10 or 20, 30 kilowatt per square feet. That's a lot. And so if you produce this much heat within using this much energy and produce so much heat within a small area, moving the heat away, that's really a big challenge. And that's where the liquid cooling, immersion cooling or direct to chip cooling comes into play. So, but this cooling part is called server level cooling. The job is to move the heat from the server to the facility or to the building, to the heat exchanger. But this has nothing to do with water. When we talk about water, it's really the outside or the facility level cooling. We need to move the heat further away to the outside environment. And so the heat power density is more related to the server level cooling and has nothing, doesn't involve water at all, doesn't involve water consumption at all. And a lot of innovation is happening within the data center to deal with the power density or heat load within a small space. In general, I think the newer cooling system like direct-to-chip cooling can reduce the energy consumption compared to air-based cooling system. And also it can tolerate a higher temperature set point at the outside. So in general, it reduces more energy directly. And also it reduces the cooling water consumption rate at the outside to some extent. So yeah, that's being used more and more.
So thank you so much, Chalet. It's clear this is a really, really interesting topic. The Q&A keeps getting more and more questions added to it. I haven't even read to the bottom. Unfortunately, though, we are actually over time. And so I'm going to hand it back to Chris, but also note for everyone that we are saving the Q&A, and NLC and the EPI will look at that Q&A, and it will inform future work they do in this area. But I'm just going to hand it over to Chris to close us out for today.
Yes, thank you so much, Chalet and Arti, for this wonderful discussion, and thank you for bringing your expertise and insights. And thanks to the audience, again, for all the questions and engagement. We are going to continue this conversation. Please look out for an email from Kate and myself that will indicate when future webinars are, in addition to some of the resources and the links for the fact sheets that we shared in the chat. But thank you all so much. We do have a post-event survey that's also in the chat. It'll also pop up on your screen when you leave the meeting. We'd love to hear your feedback so that we can continue to provide webinars and events and resources that meet everyone's needs and curiosities. So with that, we'll close the session. And thanks again to our speakers, and everyone have a great day.
Thank you.